Hi, my name is Renee Rizzo. This will be a teacher-facing video which will guide you through my adaptation of Earth Science Unit 9, Day 10 in the New York City Department of Education Teach Hub for students in alternate assessment settings. So, Earth Science Astronomy, Unit 9, Day 10. This lesson is about the shapes of orbits. The focus question, which I used from the original lesson, is what is the shape of an orbit? The objective, which I also used from the original lesson, is students will compare orbits of different planets in our solar system in order to determine the actual shapes and eccentricities of their orbits. So the standards I believe were addressed. Next generation learning standard. Integrate and evaluate multiple sources of information presented in diverse formats and media in order to address a question or solve a problem. The DLM essential element that's related to this next generation learning standard. Analyze information presented in different media on related topics to answer questions or solve problems. Both of these standards are on the 11th through 12th grade level. So, objectives taken from the original once again. Explore different types of orbits, compare orbits of different planets in our solar system, and determine the values of an eccentricity of 0 and an eccentricity of 1. Why are most celestial orbits elliptical? Wild AC video. This was a video that was included in the original lesson, and for that reason, I won't show you the video, but just know that I used this same video. Which picture represents a hyperbolic orbit? So, what I did was I took screenshots from the video because oftentimes students in alternate assessment settings require visuals to be able to interact with the material. And since these visuals were included and described in the video, I thought this was a good place to start. So, the correct answer for this question is that B represents a hyperbolic orbit. Which picture represents a spiral orbit? Once again, screenshots from the video. The correct answer to this question being that C represents a spiral orbit. Which picture represents an elliptical orbit? So, same screenshots from the video, and the correct answer to this question being A represents an elliptical orbit. So, what is an ellipse? They describe it in the video. I give students three multiple choice options: A, a circle, B, an oval, or C, a swirl, excuse me. So B, an oval would be your best answer. What type of orbit does Earth have? This is also reviewed in the video. The choices are A, hyperbolic, B, spiral, or C, elliptical, with the correct answer being that Earth has C, an elliptical orbit. What is an orbit's eccentricity? A, how perfectly circular it is. B, how squashed of an oval it is. Or C, how square it is. So the correct answer being B, how squashed of an oval it is. So examine this table to answer the following questions. So this table was included in the original lesson. It goes over the celestial object, the mean distance from the sun, the period of revolution, the period of rotation at the equator, the eccentricity of orbit, the equatorial diameter, the mass, and the density. Now, these terms may all seem complex for your students, but when you look at what I'm actually asking in the next few questions, I'm asking students to go over terms like largest, smallest. So even if they don't know what the heading terms mean, you probably have gone over place value and numbers with your students. So you should be able to engage with this table, even though the information presented seems complex. So, which of the following planets has the largest diameter? So, the choices are A, Jupiter, B, Mars, or C, Mercury. So, looking back at the table, right, we're going to go to diameter. It says Jupiter has a diameter of 142,984. Mars has a diameter of 6,794, and Mercury has a diameter of 4,879. So even if your students don't know what diameter means, they can see that Jupiter has the largest value for this particular category. So the answer here would be A, Jupiter. And I would definitely recommend going back to the table with your students, going into detail about which number is largest and which number is smallest. So you would follow the same procedure for which of the following planets has the largest mass: A, Jupiter, B, Saturn, or C, Neptune. So going back to the table, looking under mass, for Jupiter, we have 317.83. For Saturn, we have 95.16. And for Neptune, we have 17.15. So the answer would once again be A, Jupiter. Which of the following planets has the most eccentric orbit? A, Mars, B, Mercury, or C, Saturn? So going back to the table and looking for the eccentricity of orbit, if we look at Mars, it is, let's see, 0.093. If we look at Mercury, it is 0.206. And if we look at Saturn, it would be 0.054. So the planet with the most eccentric orbit would be Mercury. Now, obviously, to do this lesson with your class, knowledge of place value and the values of numbers, also comparing numbers from largest to smallest, is necessary prerequisite knowledge for your students to have, or at least be able to engage with, in order to be able to interact with this lesson. So finally, as a class discussion, you can discuss with students, what do you remember about the different types of orbits, and what did you learn about the term eccentricity? So just to review, this was a teacher-facing video in which I guided you through my adaptation of Earth Science Unit 9, Day 10 in the New York City Department of Education Teach Hub for students in alternate assessment settings. Thank you for watching.